we are going to look at this infinite case. I will tell you a simple problem. Uh, and this simple problem in transient heat conduction, I'm not going to solve it fully. I will leave it for you. You can refer to any textbook to actually understand it in detail. But for now, I'm giving you this problem to look at. See, when it comes to the infinite case, when it comes to the infinite problems case, you will find the word center line or mid plane or center. These kind of the words are seen, or central axis also sometimes in the problem. Whenever this kind of words are there in the problem, that problem will be a problem from infinite case. See, in this particular problem, you can see the center plane. The word, can you see this? This is center plane. So this particular problem has to be solved using the infinite infinite model. So infinite model means you have to use the infinite case in the data book. Okay, in transient heat conduction, go to page number 72. In page number 72, you will have this infinite solids. See, infinite solids, a very important thing is the given slab has been taken in two different space, like two different halves. That is, whole thickness is made into two, and then L is considered here. Whatever the L that is used here in these formulas, that L is only half of it. Okay, because here a symmetry is considered. Symmetry is considered, and then L is taken only on one side. Okay, so the thickness will be 2L. Okay, whatever the value that is given to you in the problem will be a 2L. Okay, now let's move to what is given here. So the slab of thickness 15 centimeters means 2L is given here. It is 15 centimeters. We have to follow the nomenclature of the data book. Okay, then initial temperature is 30 degrees centigrade, and suddenly exposed to the atmosphere of 600 degrees centigrade, and H is equal to 65 watt per meter square Kelvin. And the property values are given here. The time is given here. It is 20 minutes. And the property values are like the density. Rho is equal to 3550 kg per meter cube. Cp is equal to 586 joule per kg Kelvin. And then K, thermal conductivity 19.5 watt per meter Kelvin is given you, and he's asking you to determine the temperatures at both surfaces and at the center plane. He's asking after 20 minutes. That is the temperature that is there on this surface, and temperature that is existing on the center plane. Okay, what are the temperatures he's asking? What is the temperature here? Temperature here, temperature here. Also is asking what is the heat flow? What is the Q through this? This is the question that is being asked. Okay, for any given problem in infinite solid, there will be three cases. Okay, uh, let us say if he has given a plate, okay, like the kind of one we have got in this problem is given a plate. Okay, here you can see this is a plate. In the data book, we will have three figures for the plate. This is the number one figure, number one graph, and this is a number two graph. This is number three graph. Okay, first graph is a graph wherein you will be having the time history at mid plane. Okay, if you are using the temperature values for the mid plane, if you want to calculate the temperature values for the mid plane, you have to use this particular graph. And then next one is temperature time history at any other position. Okay, at any other position means X. See, in question what he has asked is at other positions. These are the other positions. For this, you'll be using second one. Second figure you will use. Okay, I'm sorry. Let me write it here itself. For this second figure, for this one, you have to use first figure. For this one, you have to use third figure. Okay, so go to the data book, look at all those things. Okay, calculate the x-axis value first, then get the HL by K value. After getting the HL by K value, you will get so and so y-axis value. In y-axis value, Ti is known, T infinity is known to you. Only unknown is T naught. You'll be in position to calculate what is the T naught from this. That will give you the temperature that is prevailing outside. That is here. Okay, on this one. Okay, according to him, the center plane temperature is T naught and Ti is initial temperature. Tx by L is so and so x. Okay, so using this one, you will get T naught. T naught is center plane temperature. You are done with center plane temperature here. If you use this graph, the same procedure will be followed here. And using this graph, see here you will have Bayes number, there you will have Fourier number. That's the only difference. Using this, you will be in position to calculate what is T x by L. That will be giving you T at x is equal to L. Okay, so x by L means here it is L by L, which is equal to 1. So you have to use this graph in this particular problem. Then he's also asking you the heat flow, that is Q by Q naught. He's asking you, Q is unknown. If you are in position to get the value of Q by Q naught from this, you can calculate what is Q. So for that, you'll be using Bayes square into Fourier here. Bayes square into Fourier on the x-axis. And here it is Bayes number. Anyways, we have found out both the numbers in the previous graphs itself. And use that in this graph. And you'll be getting the x-axis value. Once you get the x-axis value, you will get so-and-so graph. Then for that particular graph, what is the y value you'll get? You'll be in position to get this Q by Q naught value. Once you get the Q by Q naught value, the next thing is you have the formula for Q naught here. The formula for Q naught is given to you here. Okay, the data book, you can see it. This is your Q naught value. Once you know the Q naught value, you can substitute into Q by Q naught and calculate what is the Q value. So students, I hope it's clear for you how to solve this particular problem.